Welcome to the session number 17 from the playlist of wave optics. The topic is the intensity of the resultant wave, and based on this topic I have selected one question which is written here on this board. The question is, in the Young's double slit experiment, the intensity at 2 points for the part difference lambda by 4 and lambda by 3 are I1 and I2 respectively. So if I0 is the intensity produced by each one of the slits, then I1 upon I2 is equal to, we have been given 4 options here and we have to find the correct one. So we know that the intensity of the resultant wave I is equal to 4 times I0 into cos square pi by 2, where I0 is the intensity produced by each one of the slits and phi is the phase difference. So, and there is one more formula which relates the phase difference with the part difference. So, phase difference phi is also equal to 2 pi upon lambda into x, where x is the part difference. So, in the first case, the part difference is equal to lambda by 4. So, if the part difference is equal to lambda by 4, so in the first case, say the phase difference phi 1 is, in the first case, if I am taking the phase difference as phi 1, then phi 1 will be equal to 2 pi upon lambda into the path difference, which is equal to lambda by 4. So this is equal to pi by 2. So in the first case, the phase difference is equal to pi by 2. In the second case, let us say the phase difference is equal to phi 2. So phi 2 will be equal to 2 pi upon lambda, and in the second case, the part difference is equal to lambda by 3. So this is equal to 2 pi upon 3. So in the second case, the phase difference is equal to 2 pi upon 3. Now, the intensity of the resultant wave is equal to 4 times I0 into cos square of phi by 2, where phi is the phase difference. So in the first case, let us say, the intensity is equal to I1. So I1 will be equal to 4 times I0 into cos square phi 1 upon 2. So this is equal to 4 times I0 cos square. Now here the value of phi 1 is equal to pi by 2. So this will be equal to pi by 4. Now cos pi by 4 is equal to 1 upon root 2. So if I square it, then it will be equal to 1 by 2. So I will be getting the value of I1 as 4 into I0 into 1 by 2, or this is equal to 2 times I0. Now in the second case, I2 will be equal to 4 times I0 into cos square phi 2 by 2. Now phi 2 is this is the phase difference. So in the second case, the phase difference is equal to 2 pi by 3. So this will be equal to 4 I0 cos square. The value of phi 2 is 2 pi by 3. So if I put the value of 2 pi by 3, so this will be equal to 2 pi by 3 into 2. So this 2 and 2 will get cancelled out. So I will be getting the value as 4 I0 cos square pi by 3. Now pi by 3 is equal to 60 degrees. So the value of cos 60 is equal to 1 by 2. So this will be equal to 4 I0 into 1 by 2 whole square, which is equal to 1 by 4. So finally I will be getting the value as I0. So the value of I2 is equal to I naught and the value of I1 is equal to 2 I naught. So the value of I1 upon I naught, so I1 upon I2 is equal to 2 I naught divided by I naught, and this is equal to 2. So the correct option is B, that is 2. So in this question, the most important thing was the utilization of these two formulas. That is, the intensity of the resultant wave is equal to 4 times I naught into cos square phi by 2, where phi is the phase difference and here I naught is the intensity produced by each one of the slits. And the second formula, the second important formula which was utilized in this question was that the phase difference is equal to 2 pi upon lambda multiplied by x, where x is the path difference. So thank you very much for joining this session. In the next session, I will be taking up the another question which will be based from a different topic, but it will be from the same chapter, that is wave optics. So till then, have a nice day. Bye.